Actuators move the slide into position before injection and pull the slide back before part removal. The three forms of actuators used are the mechanical, pneumatic, and hydraulic. The mechanical actuator is the most common and uses actuator pins, also known as horn or angle pins. Actuator pins are made of hardened steel and are mounted opposite the slide block in the cavity plate at an angle. To simplify construction and installation, many actuator pins can be equipped with angled or rounded heads. During mold closing, the actuator pins engage with holes machined into the slide block and force it forward. As the mold opens, the actuator pins remain with the slide block until it is in the back position. The length of engagement equals the amount of distance the actuator pin travels within the slide block. The length of engagement and the angle of the actuator pin determine the amount of movement and force applied to the mechanically actuated slide. Calculating the slide's length of travel is done by multiplying the length of engagement by the sine function of the angle. This dimension must be greater than the depth of the undercut being removed in order for the slide to work properly. Increasing the angle of the actuator pin increases the length of travel, yet more wear is induced on slide components. With this in mind, high production molds typically use actuator pin angles of 10 degrees or less. Mechanical actuators can also be utilized in a two-stage ejection system. The first stage actuates the slide, and the second stage ejects the part. The slide's length of travel in this system is calculated by multiplying the ejector plate's length of travel by the tangent function of the actuator pin angle. Pneumatic actuators use an air-powered cylinder to move the slide back and forth. To control the pneumatic cylinder, an auxiliary function on the machine or a pneumatic pump linked with the machine is required. These systems can actuate the slide faster than the mechanical method and induce less wear on the slide assembly. Pneumatic actuators are ideal for high-speed applications, in which the slide has little detail and can be easily pulled from the part. Hydraulic actuators also require an auxiliary hydraulic pump, or an auxiliary function such as core pull to control the movement of the slide. Hydraulic actuators apply a greater force to the slide than pneumatic actuators. When hydraulic or pneumatic cylinders are used, it is the respective pressures that hold the slide in place during ejection. A proximity sensor located on the cylinder is used to signal the molding machine when the slide is in place. A slide lock holds the slide in place during injection. A heel block applies pressure to the slide block when the mold is clamped. Due to the forces applied to the heel block, a small wear plate can be used to ease replacement when wear is evident. The angle ground onto the back of the slide block corresponds with the angle on the face of the heel block. This angle is typically 10 to 20 degrees and locks after the slide has been put in place by the actuator. If actuator pins are used to push the slide forward, the angle of the slide lock should be approximately 5 degrees higher than the angle of the actuator pins. This is done to minimize the force applied to the pins.